Hello world. This video is a modeling of numerical method for differential equation. We would like to express our special appreciation towards Dr. Saratha Satasivam for her support and constant supervision. This video is presented by Siddhi Patimazian Pakrudin and Siddhi Nuradaya Matanya. Background research. The story began with a famous and super talented young man as the executive director for Sunstar Company, named Mr. Kevin. He is among the successful director in Malaysia as he started holding the title of executive director at the age of 24 years old. He is mainly known for the ability of attracting new partners and new customer into the company. Fine night on Friday, 27 of November. Mr. Kevin is scheduled to a meeting with his new customer to discuss about the agreement with Sunstar Company at the Golden Club Cafe at 9 p.m. But he never showed up at the cafe until the new customer called their office. All the staff in the company started to worry because Mr. Kevin never brought any trouble to the company. After a few discussion, the staff members conclude that Mr. Kevin's last appearance was at 5 p.m. after office hour. Later, two of the staff members went to Mr. Kevin's house to check whether he is at home or not. Unfortunately, only Mr. Kevin's sister, Miss Anna, was there. Later, around 1:30 a.m., Miss Anna received a call from police officer. Claimed that they found Mr. Kevin's corpse near Buntar Lake at 1:05 am. The police now are investigating the time of death of the corpse. Therefore, we decided to conduct an investigation so that we can see how the time taken for the body to cool down will affect the temperature of the body. Then we let the capital T be the temperature of the body in degrees Celsius, and the lowercase t be the time taken for the body to cool down in hours. We start our investigation with initial time taken equal to 0, and initial temperature of the body equal to 32. We also want to calculate the temperature of the body for time equal to 1, 2, 3 and 4. Induction. Newton's law of cooling states that the rate of change of the temperature of an object is proportional to the difference between the temperature of the object and the ambient temperature. Then, this can be written in mathematical term as d capital T over d lowercase t equal to negative k times with temperature of the body minus ambient temperature. Some explanations are as follows. If the temperature of the object is hotter than the ambient temperature, there will be the declining in temperature of the object. Next, if the temperature of the object is cooler than the ambient temperature, there will be an increasing in temperature of the object. And if the temperature of the object and the ambient temperature are pretty close, then the rate of change should not be very big. For this video we consider if the temperature of the object is hotter than the ambient temperature, then it should be cooling and the temperature should be decreasing. The decreasing in temperature will imply a negative instantaneous change, then we have negative k for the rate of cooling. Mathematical model. Let's solve this differential equation for the general solution. This is separable differential equation as the variables can be separated. We just need to algebraically manipulate this differential equation so that all capital T and d capital T are on one side and all lowercase t and d lowercase t are on one side. We have to note that capital T be the temperature, lowercase t be the time taken, and k be the rate of cooling. Then we solve the differential equation by integrating both sides of the differential equation and raise exponential to both of that powers. Since exponential power of c is an arbitrary constant, then we let exponential power of c equal to capital C. Therefore we get the general solution. The solution to the differential equation gives two exponential functions, which are equation 1 and equation 2. For this case, to identify the temperature of the body at certain time, equation 1 will be used. Then we use that equation to compute the value for C by using the initial condition, which are initial time taken equal to 0 and initial temperature of the body equal to 32. After that, we compute the value for K, the rate of cooling, by using the time taken equal to 1 and the temperature of the body equal to 31. Hence we get the model of ordinary differential equation T equal to 12 exponent to the power of minus 0.087011 times D plus 20. Objectives. Our objectives for this video are: for the first one, we want to identify the uses of differential equation that relate to our daily life. Next, we want to observe how the time taken for the body to cool down will affect the temperature of the body at certain time. And we want to enhance our understanding in solving real-life problem by using numerical method. Investigation. On Friday, 27 of November 2020, after working hour at around 5 to 6:30 p.m., Mr. Kevin met his colleague, Mr. Afik and Mr. Lee, to discuss about the agreement for their new clients at the office. Next, at around 6:30 to 7:30 p.m., Mr. Kevin coincidentally met his old friend, Sam, and continued to catch up at the nearby cafe. The last person that Mr. Kevin met was his friend, also his biggest competitor in business field. Based on a recording from one of the CCTV near Buntar Lake in between 8 to 9 p.m. They spotted on a superbike wearing a helmet, but his plate number was clearly shown. From the investigation of Mr. Kevin's phone, the police came out with the data from his call log. It stated that Mr. Kevin's last received call was from an unknown number for around 1 minute. The police suspected that it was his competitor that was spotted on a superbike at Buntar Lake due to the plate number registered was linked to the unknown phone number. The police then continued to investigate the suspected candidates. Results. We tabulate our data in a table here. The table shows the time taken for the body to cool and the temperature of the body. Notice that for every 1 hour, the body temperature decreases for around 1 degree Celsius. Here is the graph to investigate the trend of time taken for the body temperature to cool down versus the body temperature of the corpse. From the graph, we can see that as the time taken for the body temperature to cool down increases, the body temperature of the corpse decreases. Thus, we can analyze that the trend for this graph is decline steadily. The body temperature of Mr. Kevin to be as the human body temperature, which is 37 degrees Celsius, to approximate the time of death. Hence, we obtain T to be equal to -4. Thus, we get Mr. Kevin's time of death is approximately 4 hours before the police found the body. Therefore, we can conclude that Mr. Kevin's time of death is approximately at 9:05 p.m. on Friday, 27 of November 2020. Conclusion. By using Newton's law of cooling, we can make a reasonable prediction of the change in temperature for a cooling object in a constant ambient temperature. Next, we can observe the time taken for a body to cool down. And the last one is, we can enhance our understanding in solving real-life problem by using numerical method for differential equation. References. The first reference is obtained from Dr. Saratha's lecture note, Numerical Method for Differential Equation for the Academic Session 2020-2021. The second one is from a YouTube video. And lastly, we seek some informations from Wikipedia. That's all from us. Thank you, have a nice day and stay safe wherever you are.